Okay, in terms of OTN alarm flow and their understanding, in this video we will be covering 10G LAN PHY signal carried over OTN. So 10G LAN PHY signal, the scenario will be generated from this client box and then will be delivered at client box at another end. So this will be the general scenario, and for basic understanding I will clear here a few points. That local point will be the alarm where the alarm is detected and declared, and then upstream is the node in the left side in this case. So means it is if the signal flow is this side, then this node will be the upstream for this node. For this node, this is the upstream node, and in the forward direction there will be downstream nodes. So for this A end, B end is downstream. For B end, this client at B end will be the downstream. And using this with the help of equipment related document, we will be describing these alarms, and in taking different type of scenarios of without enabling the ALS or LPT function, and by enabling one by another one. The scenario, which is the first simple scenario where ALS and LPT is disabled. This is the same scenario here. So first scenario is having the 10G LAN PHY signal, and on OTN tributary boards, automatic laser shutdown and LPT link pass through is disabled. So at A end of OTN, if there is a signal coming from client, so in this client signal is not shown, so there is a signal coming from client, and then if there is any fiber cut kind of scenario, or client equipment is port is shut or faulty, or patch codes having some issues, at client A there will not be any power, and this will trigger an alarm to NMS, that is R loss. So received signal, loss of signal, that is the full form, and that alarm will be triggered to NMS, and then subsequently there is a default code is inserted towards the downstream. So this is the downstream, and when this code is received at tributary board, it is processed and a remote signal failure alarm is triggered, and the code which has been inserted by upstream of this node. So from here, so for this node this is the downstream direction, for this node this is coming from upstream direction. That code which was inserted from site A is transparently transmitted towards this equipment. In this case it is a client equipment, and the output of that default code, it is read by client equipment, and that will give a local fault alarm. That client equipment, once getting a local fault alarm, that equipment will send a insert remote fault, and that will be triggered or shown here at site location B of OTN. So there will be a remote fault. So in general cases, provider network is between this to this, if it is point-to-point network, and then the provider network NMS operator can observe only this alarm, R loss, remote signal failure, and remote fault. But if these further network also belongs to operator, then this kind of scenario, I'm just pasting it for understanding. So this kind of scenario is being created. So now, excuse me, so I will take it different. So I will take, yeah, so kind of this type of scenario is there. So when the fault is triggered here, this will be treated as another side tributary board, and then you get a local fault here. So that becomes the similar kind of a scenario as of this second case. So if I get a local fault from somewhere, then what I do? So if I get a local fault, I send a remote fault, and further I will insert that default code local fault towards my downstream, and same scenario is getting repeated at, maybe this is C, this can be called D. So this becomes C, in this case this becomes D. So in manuals, in scenarios, we always study only one direction and get confused, but we need to understand it carefully with what kind of a scenario we have. Is the client which is mentioned here belongs to customer, or it belongs to the same operator, and further the impact is the same. Like now I will explain that local fault. So when I get a local fault, then at B and at downstream end the results are the same: remote signal failure, and then local fault is inserted, and then I'm getting back the remote fault. So the same scenario is occurring here. So one thing to understand very carefully, that when I get a local fault somewhere, I'm getting in this case local fault here, there is no problem between this board and the upstream board. The problem is beyond the upstream board, which is directly connected. So local fault is coming here, then the immediate upstream do not have an issue. Means there is a signal coming here, and in that there is a default code coming here, and that is giving the impact. So if local fault means beyond the equipment connected to this port, the problem is there. So we need to diagnose and understand the scenario like that. So now we go to the third thing, that if I get errors, so if there is a problem between this end equipment and the A direction tributary board, then if these errors are very high, then we indicate kind of performance event, and at the line boards of both directions nothing is processed, and transparently these bits are transmitted to the downstream client. So now we go back to this place, and in this case we have explained. Now as per the figure 2, we are going to study the alarm flows in a bit transparent 10G LAN PHY over OTN if the problem is between the line boards, or you can say two OTN boards which is processing the OTN signal, and there is a from A direction 10G LAN PHY is riding on OTN. So as such this diagram may look kind of a complex, but for easy of understanding I will explain that at any OTN board, if the alarms, any type of alarm is signal failure type, means service affecting type. Then consequent alarms and their responses are the similar. So we need to understand those OTN alarms in two categories. One is signal failure type, another one is signal degrade type. So signal degrade type, we will come across to that later on. So signal failure type alarms, if I am getting AIS, so my complete signal is all ones. So AIS is alarm indication signal, but it is triggered when the frame in most of the part of the frame, it is made all once by the upstream direction. OCI is the another signal failure type, which is open connection indication, which indicates that at upstream direction some cross connection is missing. So it is also signal failure type. And the lock alarm. So lock alarm is when operator or any administrator takes some trail under maintenance. Then it also is a situation where because its control is taken, so traffic is not flowing, and so that is also categorized as signal failure type. In the similar manner, if see these alarms at OTU layer comes, so that was at ODU layer, but OTU layer AIS or loss of multi-frame and loss of frame at OTU layer, which is clearly a signal failure, because if at AIS at OTU layer, if AIS is coming, definitely at ODU layer and at client layer there cannot be any signal, there cannot be any traffic, usable traffic from upstream direction. And this is one more alarm or one more scenario in terms of alarm, that trail trace identifier at PM. In fact, it is not shown here, but any trail trace identifier, it is shown here the down below. So at PM or SM, so PM is nothing but trail trace identifier at the ODU layer. So PM bytes are at ODU layer and SM bytes are at OTU layer. So if I get a TIM mismatch or trail trace identifier mismatch, then I will trigger then this node will trigger the alarm trace identifier mismatch. But the only condition we need to take care of it, that whether or not the TIM follow-up action is enabled. So TIM follow-up action enabled meaning is, if you get a trail trace identifier mismatch and you don't want to get it, or you want to bring down your system if there is not the signal which you get is not the one which you are waiting for it, then you bring down the network. So then also it becomes a signal failure type of scenario, but otherwise it is not. If you do not enable the action follow up from TIM, then this remains of no use. There is no further flow of the alarms. So in terms of signal failure type of alarms, the insert local fault goes in the same way like the earlier scenario. So in the tributary board side, there is a tributary board inserts a fixed pattern, which means a local fault at the receiving end. So in this case, the downstream client will trigger a local fault, and the action for local fault is same. So it will send it on the remote fault back, and that would be triggered at site B tributary board. In OTN alarm, there are separate topic on that. So in OTN alarm, if there is a signal failure type of alarm, it has to be informed back to the upstream direction. So any signal failure type of alarms are informed back to the upstream. So if I'm getting audio layer of alarm, I'm informing back as a audio BDI. So audio PM BDI, in case we enable TCM, then audio TCM BDI. So BDI is common in SM, PM and TCM bytes. So SM is audio layer of overhead byte, PM is audio layer of audio overhead byte, and similarly TCM is also at audio layer byte, which can be also used. The function is almost the same, but the TCM is also used to monitor the signals across the operators. So if there are different operators, there are lot of TCM byte groups, 6 TCM1 to TCM6, so that is used. In terms of OTU signal failure, information back goes as a BDI at audio layer. This is like we need to note down. So if I get a signal failure at audio, I inform back to my upstream at that same level, and the below levels if it is there. That we will study more in detail in OTN alarm signal flow. But if there is a OTU layer of signal failure, then information goes back in terms of OTU layer and audio layer both, and down below. So if I get a OTU, this is OTU and audio, and the below audio. If I get a audio, same level of audio and the below audio if there is any. And further alarm actions is the same: local fault, remote fault. It inserts local fault, client may trigger on in their NMS if it is there. If I consider the client as a customer, if it is operator, then that system will trigger a local fault, and the consequence back is the same. In case of TIM, if an action is enabled, response is enabled, the results are the same. In case of now signal degrade type. So signal degrade type at OTN is monitored by BIP, the PM, there is a byte BIP 8 in the PM, also in SM. So at OTU layer and at audio layer. So first is audio layer, second is OTU layer. So that BIP 8, there is a computation happens, and then after 2 frames the results are inserted, and then they are compared at B end, and if there is a problem, the degradation or the excessive alarms are triggered. These are the condition based on what type of degradation you want to check. There is 2 type of poison and bursty. So based on that, these 2 type of alarm, we are not going in detail here right now. And so that is the OTN layer of alarm. And once I get the degraded, then as per the OTN alarm flow, the audio PM remote and bitter performance event is captured by upstream. So alarm for the degradation is triggered at B, and then in the upstream direction there is a performance event is sent and captured by A. So similarly, the degradation case happened at OTU layer. So it is sent back as a OTU remote and bitter performance event. In forward direction, without doing any computation at the client board or tributary board of B, the errors are forwarded to B. So there is one very peculiar thing, that because this performance event is just monitored, so in case we customize the degradation threshold very lazily, then even if this is the customer, they are complaining, it is very difficult to find out the fault. So we need to go and see the performance if there is no alarm is coming, and if there is a remote and bit error performance is there, then we need to look at the threshold set for checking the degradation or excessive errors. Now in scenario 2, where we are now taking one by one. So in this case, link pass through is enabled and ALS is disabled. Please note, we cannot make them on, we cannot use them together. So if LPT enabled, this has to be disabled. So there is nothing special here. So in this case, if the first figure out of this scenario 2, which is figure 3 in this case, if there is a R loss at site A from client equipment, then the alarms will remain the same, actually without LPT, whatever alarms are there for the section. So R loss is considered remote signal failure, but there is one thing, that rather than transparently transmitting the pattern which has been inserted by the upstream, the laser is made of, because this is a LPT action link pass through. So link pass through, the main layman purpose, if we want to understand, so in Ethernet technology, if A end is having some problem, then that has to be conveyed to B end. Okay, so it's a problem with like total signal failure. So the total signal failure is conveyed in the form of making the laser off here. So there is another actually requirement of this, that some signals, when getting over to another transport technology, the end-to-end alarm flow to the users, which is routers, so they do not understand whether the end-to-end signal is through. So in between, because there is encapsulation, so the control bytes or the byte which carries the information of some issues, those in some cases is not carried, that is stripped while doing the encapsulation. So like in GFP framing, there is option of curtailing the bits, curtailing the overhead bits of the input signal. So then it becomes very much necessary at B end to inform in some form. So LPT is a solution. So by using LPT, if there is a remote SF alarm, the laser will go off. So there are conditions of triggering LPT. So in remote SF is one of them. So once the remote, because of remote SF, laser is off, at this end there is no signal, so R loss. So R loss or local fault, the trigger back is the same, so it will be informed back as a remote fault. So one more thing in LPT is, this is not only one side laser off, because at this end there is no signal. So this interface of this client equipment receiver signal should get also some kind of trigger. So in case of LPT, this laser is enabled. So laser laser shutdown is enabled. The only difference, it will be on and off. So it will be on for 1.5 second and off for 1 second. So this laser on and off action, that is also identified and triggered to NMS, and that is LPT enabled. There will be a trigger, so you can consider this as an alarm, and LPT enable signal will be reported to NMS. In case of local fault, it is the similar, getting local fault, so problem is beyond the client equipment, and then this beyond the direction or downstream direction, the remote SF laser will be off, so R loss, so remote fault back to B end tributary, and at A end tributary, laser will be on and off. So before going to bit error, I can just explain a difference here, that in case of LPT the laser will be off both sides. Maybe that at A end it will be on and off, but the laser will be off. In case of ALS, the laser will go only into the downstream direction. Okay, the upstream direction will remain intact, so which we will cover. So this is the part of a scenario where LPT is enabled and the issue is between client and site. So this can happen this side, the result will go just reverse. Now the scenario which we study is like whenever the problem is not between client and tributary board or between the site, there is no issue between client and operator, and there is operator network is having some issue. So which we have seen it, that in case of LPT enable, these alarm of OTN will behave the same way. The outside alarms will be the same, because only thing is the laser will go off. So at the client equipment, rather than getting a local fault, it will be R loss, but otherwise at the operator end this will be the similar. So R loss, remote fault, and because this BDI, this is also laser off. So because at this direction there is a problem, so laser will be off. So in all case of failure type of alarm, forward direction or downstream direction laser will be made off, and because of the R loss there will be trigger back remote fault. In case of PM or SMTTI, if it is conditional, if it is signal failure type, the action is the same. So in case of LPT, if we observe clearly that both side LPT will be enabled, means laser will go off. In case of degradation will be triggered back. So there is no difference than the earlier one, because LPT will not act based on the degradation in between the section. So between line to line there will be alarms at OTN layer, and there will be event performance, event captured at upstream, and the errors will be passed on to downstream direction. So client B will get error, and if there are triggered threshold set, it will show some alarm. So now we will go a little faster. The third scenario is just having ALS enabled, LPT disabled. So if there is a problem between client and site A, there will be alarm remote SF, laser will go off, there will be R loss, and remote fault will be coming back to the tributary board. So if this operator only own this much, there will be R loss at one end, and at B end remote SF and remote fault, and additionally laser will be off by the action of laser ALS, automatic laser shutdown. So then there will be a trigger of ALS enable, some kind of trigger in NMS. For local fault it is remote SF. So in case of local fault there is slightly difference. There is no problem as such between this client to this tributary board. So this will be similar to the without enabling anything. So remote SF, and then it will be that insertion of the transparently transmit local fault inserted by upstream will be passed on to client, and the result of local fault is remote fault. Okay. So yeah, I think in upper scenario we missed the bit error, but that can be covered here, which is SIM. So if we get a alarm, we get errors from client, the bit errors will be detected, and if we configure them based on that, alarm will be triggered, otherwise not. And in the B and downstream direction, it is transparently transmitted. In the last case, when ALS is enabled and the problem is between the line boards, means in the OTN network, then for signal failure type of alarms, trigger back will be the same. Forward direction laser will be made off, so ALS enabled alarm will come. There will be intimation to NMS, and R loss result is the low remote fault. And in all the cases, so conditional signal failure of TIM, SM or TIM PM is we have explained. So laser will go off. So in this case, if you see clearly that only in the downstream direction laser goes off. If there is any problem between upstream client and tributary board, or in between. If there is no problem in the upstream directions client and tributary board, if there is a local fault only, ALS does not act. So that is the slight difference between LPT and ALS and those alarm signal fault flows. So we need to be very careful about what segment of the network is owned by the user or owned by the network operator, and the user is looking at which type of alarm. So this is the general understanding. Thank you very much.